The Palace of Versailles, architecture, construction and engineering. Imagine for a moment the most ambitious architectural project in Western history. A palace that took 47 years to build, employed 36,000 workers simultaneously, and cost the equivalent of 25 billion euros today. A project so monumental that it forever transformed the way we conceive architecture and power. We are talking about the Palace of Versailles. But what many don't know is that this architectural marvel began as something much more modest. A simple hunting lodge in the middle of a swamp. The story of Versailles is the story of how human ambition, combined with architectural genius, can transform the impossible into reality. It is the story of three visionary architects, revolutionary technical innovations, and the most complex challenges that 17th century engineering could imagine. Today we are going to discover how Versailles was really built. It all began in 1623, when Louis XIII decided to build a small hunting retreat 20 kilometers from Paris. The chosen location could not have been less promising. A swampy area with a high water table and unstable clay soil. Any sensible architect would have advised finding another site. But architect Philibert Le Roy accepted the challenge. He designed a modest but elegant structure. 3 stories high, just 24 meters of facade, built with the combination that would become the seal of French architecture. Red brick, white stone and slate. The plan was simple, U-shaped, with a central honor courtyard. Nothing extraordinary by royal standards, but Le Roy had established something crucial. The architectural principles that 4 decades later, Louis XIV would amplify to create the marvel we know today. This small chateau had a characteristic that would prove prophetic: its perfect proportions. Though modest in scale, it possessed that mathematical harmony that 17th century French architects had inherited from the Italian Renaissance. Without knowing it, Le Roy had created the genetic nucleus of what would become the largest palace in the world. In 1661, when Louis XIV was barely 23 years old, he made a decision that would change the history of architecture. To convert his father's modest hunting lodge into his main residence. It was not a practical decision. Paris offered the Louvre, much more convenient and already established. But Louis XIV was not seeking convenience. He sought to create something that had never existed before. His vision was revolutionary. A palace that would not only be a residence, but a theater of absolute power. A place where architecture itself would communicate the greatness of the king and of France. Where every stone, every window, every garden would proclaim to the world that the French monarchy had no equal. To materialize this vision, Louis XIV summoned architect Louis XIII. XIII faced a fascinating dilemma: how to transform an existing structure without destroying its character. How to create something monumental while respecting what was already built. Louis's solution was brilliant. He decided to create an architectural envelope. Instead of demolishing Louis XIII's chateau, he surrounded it with a new stone construction. maintaining the original marble courtyard as the ceremonial heart of the new palace. This envelope was not a simple expansion. It was a complete reinterpretation of the concept of a royal palace. Louis XIV created the famous west facade toward the gardens, introduced the concept of symmetrical royal apartments, and designed what would be the first sketch of the future Hall of Mirrors. But expanding Versailles was not just a design matter. It was a colossal engineering challenge. The swampy terrain that had complicated the original construction now threatened to sink a much heavier and more complex structure. Louis XIV architects had to develop innovative solutions. They drove thousands of oak piles up to 8 meters deep, creating an artificial foundation over the unstable ground. They designed a perimeter drainage system to control the water table, and built retaining walls up to 4 meters deep. But the greatest challenge was not in the ground, but in the air, water. Versailles needed water for the fountains, for the court's needs, for the gardens. And the nearest place to obtain water in sufficient quantity was the Seine River, several kilometers away and 165 meters below. The solution was the machine of Marly, one of the marvels of 17th century engineering. Designed by Belgian engineer Renikin Swalem, this hydraulic machine used 14 giant wheels and 259 pumps to lift 5,000 cubic meters of water daily from the Seine to Versailles. The system was so complex that it required constant maintenance and generated a deafening noise that could be heard for kilometers. But it worked. For the first time in history, a palace had abundant running water, not because it was near a river, but because it had been brought artificially through pure engineering. In 1678, when Louis XIV had already created the foundations of the new Versailles, Louis XIV decided it was time to make the definitive leap toward monumentality. For this he summoned Jules Hardouin-Mansart, great-nephew of the famous François Mansart, and entrusted him with the most ambitious task: to convert Versailles into the largest palace in the world. Mansart was not just an architect. He was a visionary of monumental scale. His first great work at Versailles was the Hall of Mirrors, and with it he forever changed the way we understand palatial spaces. The gallery measures 73 meters long, 10.5 meters wide, and 12.5 meters high. But its physical dimensions are not the most impressive. What is truly revolutionary are the 357 mirrors that face 17 arched windows toward the gardens. These mirrors were not a simple decorative luxury. They were a technological declaration. In the 17th century, large mirrors were extraordinarily difficult to manufacture. The Venetians had monopolized this technique for decades. But Louis XIV established the royal manufacture of Saint-Gobain specifically to produce the mirrors of Versailles, breaking the Venetian monopoly and converting France into the new world leader in this technology. The effect of the Hall of Mirrors is more than decorative, it is architectural. The mirrors infinitely multiply the space, create plays of light that change according to the hours of the day, and establish a constant visual relationship between the interior of the palace and the exterior gardens. But Mansart was not satisfied with the gallery. His vision was even more ambitious. to create wings that could house the entire French court. The north and south wings that he designed each measure 402 meters in length. To put it in perspective, they are longer than the height of the Eiffel Tower. These wings were not simply long, they were functionally revolutionary. Mansart developed a system of standardized apartments for courtiers, with a distribution that optimized both privacy and protocol. Each apartment had its own service staircase, integrated fireplaces, and connection to the main galleries. The construction of these wings required unprecedented logistical coordination. Mansart simultaneously directed thousands of specialized workers. Stonemasons who carved the Crile stone, cabinet makers who created the carpentry, glaziers who installed the windows, plumbers who laid the pipes, blacksmiths who forged the railings. Each trade had its own rhythm, its own needs, its own materials. Coordinating all this required an almost military organization. Specialized workshops were established within the Versailles compound itself. Specific supply routes were created. Quality control systems were developed for each type of work. Mansart's last great work at Versailles was also the most complex, the Royal Chapel. Begun in 1699 and finished in 1710. This chapel represents the perfect synthesis between French Gothic tradition and 17th-century Baroque innovation. At 25 meters high, the chapel is the tallest structure in the entire palace. But its height is not just a matter of grandeur. It is an architectural solution to a unique protocol problem. The royal family attended Mass from a tribune on the first floor, while courtiers were located in the nave, on the ground floor. This arrangement required perfect acoustics that would allow both music and words to be heard clearly on both levels. Mansart designed a vault specifically calculated for these acoustic needs, working with musicians and singers to find the exact proportions. The chapel's decoration, the work of Antoine Coypel, had to be visible from multiple angles and distances. The vault paintings are calculated to be seen both from below and from the upper tribunes, using perspective techniques that create different visual effects depending on the viewpoint. But Versailles cannot be understood only by its built architecture. Its gardens are equally architectural, equally revolutionary. André Le Nôtre, Louis XIV gardener architect, created something that had never existed before. A completely artificial landscape that seemed completely natural. Le Nôtre worked with the same mathematical principles as the palace architects. Every avenue, every grove, every perspective was calculated according to exact geometric proportions. The main axis of the gardens extends for 3 kilometers in a perfectly straight line, creating a perspective that seems infinite. But creating this perfect geometry required moving colossal quantities of earth. It is calculated that to level the gardens of Versailles, more than 1 million cubic meters of earth were moved. Thousands of workers labored for decades to create the terraces, excavate the Grand Canal, and model each hill according to Le Nôtre's design. The Grand Canal itself is an extraordinary work of engineering. 1,670 meters long by 62 meters wide. It is not simply a decorative pond. It is an artificial port where boats arrived from Paris, and where the court held naval spectacles with ships brought especially from Venice. The construction of Versailles required materials of the highest quality, but also in quantities that challenged the productive capacity of the era. The main stone was Crile limestone, chosen not only for its beauty, but for its weather resistance. Quarries were opened specifically for Versailles, where hundreds of specialized stonemasons worked. The marbles came from all over Europe. Carrara for the noblest elements, French marbles from Reims and Bolognese for color contrasts. Each block had to be transported in ox-drawn carts through roads that often had to be improved specifically to support the weight. The carpentry required woods of specific qualities: French oak for the structure, ebony for luxury cabinetry, exotic woods from the colonies for the most elaborate marquetries. Cabinetry workshops were established within Versailles itself, where France's best craftsmen worked. But perhaps the most complex material to obtain was metal. The lead pipes for the hydraulic system totaled kilometers in length. The wrought iron for railings and balconies required blacksmiths specialized in decorative work, and the gilded bronze for hardware and decorative elements needed foundry and gilding techniques that were at the frontier of the era's technology. Coordinating a project of this magnitude required unprecedented administrative organization. Louis XIV effectively created the first modern architectural office, with Mansart as Director General of Works, seconded by specialized teams for each aspect of construction. There were quality inspectors for each material, supervisors for each trade, accountants who kept detailed records of each expense, timekeepers who measured the progress of each phase. Communication systems were developed that allowed decisions made in Paris to reach Versailles quickly, and construction problems to be reported immediately to those responsible. The logistics of supplies was especially complex. Every day hundreds of carts arrived at Versailles with materials: stone from the quarries, wood from the forests, metals from the foundries, food for the workers. Specialized warehouses were built, tool repair shops, even hospitals to treat injured workers. The peak of activity was reached around 1685, when 36,000 people worked simultaneously in Versailles and its surroundings. It was effectively a city dedicated exclusively to the construction of the palace, with its own economy, its own rules, its own social life. Versailles was not only large, it was innovative. Mansart and his team developed architectural solutions that would influence all subsequent European construction. The concept of functional apartments, with specific spaces for each activity of courtly life, established principles that are still used in modern residential architecture. The garden facade, with its 580 meters of continuous length, created the concept of unitary urban facade that would decisively influence later urbanism. The rhythmic repetition of windows, balconies and decorative elements established an architectural vocabulary that would spread throughout Europe. But perhaps the most subtle and lasting innovation was the relationship between interior and exterior. Versailles was one of the first palaces where the gardens were not a decorative addition, but an architectural extension of the building. The large windows of the garden facade established a visual continuity that completely integrated the built space with the landscape space. Versailles technical systems were also pioneering. The water distribution network, with its 35 kilometers of lead pipes, established principles of hydraulic engineering that would later be applied in modern cities. The heating systems, with chimneys integrated into each main room, optimized thermal efficiency in a way that would not be surpassed until the arrival of central heating. The cost of Versailles was colossal, even by the standards of the French monarchy. It is calculated that the total investment reached £25 million of the 17th century, equivalent to approximately €25 billion today. This represented between 5 and 10% of the kingdom's annual budget during the years of maximum construction. But the consequences of Versailles went far beyond economic cost. The palace established a new standard of monarchical grandeur that all European sovereigns tried to emulate. Schönbrunn in Austria, Peterhof in Russia, Sanssouci in Prussia, Caserta in Naples, all were attempts to create their own Versailles. More profoundly, Versailles changed the way we understand the relationship between architecture and power. It demonstrated that a building could be not only functional or beautiful, but could communicate political ideas, establish social hierarchies, and even influence the behavior of the people who inhabited it. The etiquette of Versailles, with its elaborate rituals and specific spaces for each ceremony, transformed architecture into a theater of absolute power. Each room had its protocol function, each staircase its hierarchical meaning, each apartment its place in the social structure of the court. Today, more than 300 years after its construction, Versailles remains a world architectural reference. It receives more than 10 million visitors annually, making it one of the most visited historical sites in the world. But maintaining this heritage presents unique challenges. The original 17th century materials require specialized conservation techniques. The cryol stone deteriorates from atmospheric pollution. The gallery's mirrors need constant maintenance to preserve their original clarity. The wooden structures suffer the natural wear of 3.5 centuries of existence. Current restoration projects use 21st century technologies to preserve 17th century techniques. Laser scanners document every architectural detail. Chemical analyses identify original materials to use compatible components in repairs. Discrete climate control systems protect historical decorations without altering the appearance of the spaces. The restoration of the Hall of Mirrors, completed in 2007, required 3 years of work in collaboration from specialists of multiple disciplines. Art historians, chemists, physicists, traditional craftsmen. Each mirror was individually dismounted, restored according to historical techniques, and reinstalled with millimetric precision. In the end, Versailles represents much more than an extraordinary palace. It is the perfect synthesis between tradition and innovation, between art and technique, between practical function and symbolic representation. It is the demonstration that when political vision, architectural genius and material resources combine without limitations. The result can transcend its era and become universal heritage. The history of its construction teaches us that great architectural projects are not just technical or aesthetic matters. They are total human enterprises that mobilize knowledge, resources, and energies of entire societies. Versailles was possible because all of 17th century France contributed to its creation. From the stonemasons who carved the stone to the mathematicians who calculated the proportions, from the gardeners who planted the groves to the diplomats who negotiated the importation of Italian marbles. Today, when we visit Versailles, we are not only contemplating a 17th century palace, we are contemplating the materialization of an era, the testimony in stone and crystal of what a civilization considered worthy of its greatest efforts. And perhaps also a reflection on our own collective projects, our own monumental ambitions, our own legacies for the future. Because in the end, the question that Versailles poses to us is not only how an impossible palace was built, but what we are building that can endure 300 more years.